Here we are in section 3-4, exercises numbers 29 through 35. The instructions say to stick in -4, -3, -2, -1, 0, 1, 2, 3, 4. That looks like 9 different numbers we have to stick in as the domain for each of these functions, and then sketch the graph. So that should draw to mind that we're going to be sticking -4 in, then -3, then -2, a little x, y chart into these functions and on the graph. So we'll bring those up. I've set up here that we're going to be sticking these in. We'll run through. So number 29 first. Now this is in y equals mx plus b. Back in the good old days of graphing just lines, well, we see that the y-intercept, if we stick in 0 here, we'll get -4, and we'll have 0, -4, and then it will be a shallow line upward like that, slope of 2/3. To get us into the way of doing this, we're going to run through this in the old-fashioned way of sticking in all of these points, and it'll be good preparation for these. So if we stick in -4 for x, 2 times -4, that's -8/3, minus 12/3 is -20/3. If we stick in -3, 2/3 times -3 is -2, minus 4 is -6. -2 goes in there, and it's -4/3 minus 12/3 is -16/3. Stick it in -1, and it's 2/3 times -1 is -2/3 minus 4, which is 12/3, which is -14/3. You'll notice that every time we increase 1, we go up 2/3. That's the slope of the line. That's that constant change that takes place on a line that is in a straight direction. And if we stick in 0, we get -4. And yeah, it went -20/3, -18/3, -16/3, -14/3, -12/3. So this is going to be a -10/3. Let's just double check. 2/3 minus 12/3. Yes, indeed. This is going to be a -8/3, -6/3, which is a -2, and then -4/3. And we can just double check this, like when we stick in 3, 2/3 times 3 is 2. Minus 4 is indeed a -2. So you'll notice if we plot all these points, we're at -4, -20/3, -3, -6, -2, -16/3, -1, 0, -4, and yeah, we get this line that connects all those dots right there. Alrighty, 4 is at -4/3, so all of these points would be right along that line. All right, number 30. We're going to stick in all of these into 1 over x. So these come out a lot faster than these guys did. We have a -1 over 4, -1/3, -1/2, -1. Ooh, 1 over 0. No, that is undefined. So we can't stick in 0, so we'll have no y-intercept on this one. Stick in a 1, we get 1 over 1, 1 over 2, 1 over 3, and 1 over 4. So at -4, we're barely down at -1/4. At -1/3, we're a little bit further down. -1/2, we're a little bit further. -1, -1. So it looks like this. And 0, we don't get anything. And 1, 1 is like up here. 2, 1/2. 3, 1/3, and 4, 1/4. Whoa, that's kind of weird. And just by connecting those dots, this is what we get. You can see it starts going away, and this is where we get this asymptote here. Fascinating. And this guy, just connect the dots and head on up because we can never hit 0. All right, that's kind of an interesting looking one. Number 31, square root of x. So we're going to take x's and stick them in, get square roots. So square root of -4, no. Square root of -3, no. We can't take the square root of a negative number. That doesn't give us anything. Square root of -2 is a no. Square root of -1 is a no. Square root of 0, oh, we finally get one. 0, 0 is a point. Oh, good. 1, square root of 1 is 1. So 1, 1 is a point. And then 2, square root of 2, which is about 1.4, roughly. So go up here, 2 will be about right there. And it looks like it's kind of a straight line, almost. Square root of 3, so 3, it's just barely 1.7. Not quite a straight line then. And then square root of 4 is 2. So that's just 2. That's about a 1.7, I think, somewhere around there. And so we get this curve, and it gets shallower and shallower as it goes out, like that. All right, that's what the square root function looks like. Let's clear these off and look at the next three. Number 32, h of x equals absolute value. So let's stick these numbers in for x. Absolute value of negative 4 is 4. Absolute value of negative 3 is 3. So if we stuck that right in there, that's what number pops out. 2, 1, 0. Absolute value of 1, we get those positive numbers back over. So negative 4, 4, that's 1 point. Negative 3, 3. Negative 2, 2. Negative 1, 1. 1, 1. 2, 2. 3, 3. 4, 4. And these are in straight lines. So it forms a V shape. That's what the absolute value function does. 33. Okay, b of x equals x cubed. So we're going to take this and cube each one of these x's. So negative 4 times negative 4 times negative 4 gives us negative 64. Negative 3 times negative 3 times negative 3 is a negative 27. Negative 2 cubed is a negative 8. Negative 1 cubed is a negative 1. 0 cubed is 0. 1 cubed is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Okay, so 0, 0, it goes through here. 1, 1 is right there. Negative 1 is right there. And it kind of looks like it might be a straight line, but as soon as we do the 2's, 2 is like 8. That's clear up there. Negative 2 is negative 8 and is clear down there. And then negative 3 is even further down. Negative 4 is further down. So it actually, if we try to connect these dots, it actually looks a bit like this, and it curves down. And it just keeps going. Whoa, that guy looked kind of weird. There we go. And so that's kind of what it looks like. And that's it. It just kind of curves in there, makes a little S curve there. 34. T of x equals x squared. So we're going to square these. Negative 4 times negative 4 is a positive 16. Notice when we cubed it, we kept negatives. But these, 9, negative 2 squared is 4, negative 1, stick that in there and it's positive 1. 0, 1 squared is 1, 4, 9, and 16. Now notice we have 0, 0, and 1, 1, and negative 1, 1, just like what we did over here with the absolute values. But 2 isn't 2. It doesn't come out in a straight line. 2 goes up to 4. Negative 2 is also up, so it's a symmetric shape, but it's not straight lines anymore. 3 goes up to like 9, negative 3, negative 9, and then further up. And it forms a U shape. Whoa, I missed the dots. And there you go. This is a parabola. All right, let's clear that off and look at number 35. 35, 2 to the x. So whatever number goes in here, we're going to take 2 to that power. So let's start down here at the bottom. They might be a little bit easier. 2 to the 4th power. 2 times 2 times 2 times 2. 16. Okay, now we stick in 3. We get 2 to the 3rd power is 8. 2 to the 2nd power is 4. 2 to the 1st power is 2. 2 to the 0th power is 1. 2 to the negative 1 power. Now let's write that out. Remember what negative exponents do? They put it on the bottom. So this is 1/2. This is 1 over 2 squared, so that's 1/4. And this is 1/8, and this is 1/16. So that's like 2 to the negative 4, that's 1 over 2 to the 4th. So you'll notice here are these numbers, and their reciprocals are up here. So it goes to the point 0, 1. So 1 goes up to 2, 2 goes up to 4, and it keeps getting twice as high on this side. So it almost looks like a parabola headed up there. But on this other side, you'll notice negative 1 is 1/2. Negative 2 is 1/4, and it looks like the 1 over x function almost, because it shoots off and gets smaller and smaller and smaller there. And that's an exponential function.